Hello and welcome back. In this video we will practice some questions related to kinematics. In the first question, as you can see that there is distance given between the 2 points x, for example, and y. The speed at x is 10 meters per second and at y it is 20 meters per second, and you have to find out the car's acceleration according to the equation of motion. 2as is equal to v square minus u square. By substituting the values we can find out the acceleration, and it's 1.5 meters per second square by this solution. In this question you have to find out the expression which gives the acceleration of the ball. If you go through the lecture which is related to kinematics, I did explain the gravitational acceleration is actually dependent upon h and t square, and the relation of gravitational acceleration with h and t square is actually g is equal to 2 times delta h upon delta t square. It means the gradient of this graph is delta h upon delta t square times 2 is actually gravitational acceleration. In order to find out the gradient, you will take h2 minus h1 divided by t2 minus t2 square minus t1 square. So t2 square minus t1 square, and by this you can find out that option D is correct, because you have to take square difference between the squares, not the square of the differences. So option D is correct, while option A, B and C are incorrect. In this question, distance is given and the object is falling from rest. Air resistance is negligible, so you make the data. Initial speed 0, distance is 10 meters, acceleration is 9.81 meters per second square. So s is equal to half at square, because ut is actually 0. So s is equal to half at square. You will find out time by this, which is 1.43, and you can find out the final speed by v is equal to u plus at by substituting the values given in the question. In this question you have to find out which measurements are needed to calculate acceleration of free fall. As I have already told you that g is equal to h upon t square, it means to find out gravitational acceleration you need distance fallen and the time in which the distance was fallen. Now in this question, a stone is dropped from the top of a tower 40 meters of height, and you have to find out the time taken by the stone to fall 10 meters to the ground. So I'm solving for first I am solving for 40 meters of the fall, like total journey for the stone to fall. The time taken by the stone to fall for 40 meters will be found by this solution. T is equal to 2.85 seconds. This is the total time taken by the stone to fall 40 meters. Now I'm finding out the time the stone takes to fall 30 meters, and by the solution you will find out the time the stone takes to fall for 30 meters is 2.47 seconds, which means 40 meters takes 2.85 seconds, 30 meters is taking 2.47 seconds, which means final 10 meters of the fall will be the difference between these two times, 0.38 seconds for the last 10 meters of fall. This was the time for the whole fall, which is 2.85 seconds, and this is the time taken by the stone to fall 30 meters of the fall. So last 10 meters takes 0.38 seconds, which is the difference between 2.47 and 2.85 seconds, 40 meters and 30 meters of fall. Now in this question they have given you 1000 meters distance, final speed is 0, and deceleration is also given. So you have to find out the initial speed at the yellow signal, because at the red signal the train has to be stopped. So it's easy. U is unknown, v is 0, a is minus 0.2 meters per second square, and by this you can find out A is the correct answer. A ball is thrown horizontally in still air. It means air resistance is not negligible now. The ball is affected by air resistance, right? So if air resistance is present, air resistance will affect the motion. So if I consider the horizontal motion of the object, the air resistance is actually acting on the object, making its speed lesser as the time passes, which means the horizontal speed will starts to decrease and will be 0 by the time. Now if I talk about vertical motion of the ball, initially there is less air resistance acting because of less speed, and as the time passes air resistance increases because of increase in speed, and eventually it will become equal to weight, and that will be condition of terminal velocity when the air resistance and the weight are equal and the object falls with a constant velocity. So for the vertical motion, the speed of the object starts to increase to a constant value, which is terminal velocity, and the horizontal component is actually decreasing to 0. It was not 0 in the start, but then it became 0 because of air resistance, which is affecting the motion of the object. So according to this, B is the correct answer. In this question, there are two scenarios given. One in which x is the distance in which the train is stopped, and you have to find out that if you increase the speed of the train by 20%, how much distance will it cover more so that it stops safely. So initially u1 is 1 meters per second. I've taken this speed by myself. You can take any speed. This is actually taken because of so that I can solve it easily. So I've taken 1 meters per second as the initial speed. This is my assumption, so you can take any value for your assumption as well. The final speed must be 0. The distance initially is x and the acceleration is minus a. Now final condition, initial speed is 20% more than the previous one, right? So I took 1 meters per second initially, so I am taking 1.2, which is 20% more than initial condition. Final speed is 0. S2 is unknown and A is actually minus A. Now by the equation 2as is equal to v square minus u square, 2 times minus A because it is deceleration, 0 minus u square. So I am making A subject because A is constant in the two journeys, initial and final condition. A is constant, so I am making A subject. 2a is equal to u square upon s. Now on the left hand side of this equation, 2a is actually a constant value, which means the value of u square upon s is actually constant. So I can write u1 square upon s1 is equal to u2 square upon s2, which means the value of this ratio is actually a constant which will not change. So now I am substituting the values of u1 s1, u2 and s2 to find out s2. 1 square upon x is equal to 1.2 square upon s2. So s2 is actually 1.44 times x, which is initial distance when the object had 1 meters per second speed. In this question you have to find out the ratio between horizontal distance traveled by the object in time t and the vertical distance traveled by the object in time t, and the object is actually bullet which is fired horizontally, and this is actually projectile motion. This is actually a possible path by the bullet because it was moving horizontally. Now because of its vertical acceleration it will move down as well as horizontal. So this is a possible projectile motion by the bullet. Now this is point B, this is point C. If this is B, this is Y. BY is the vertical path and CY is the horizontal path, right? So solving it for vertical and horizontal individually, horizontal distance will be speed times time. So horizontal distance is actually v into t, where v is the horizontal speed and t is the time taken by the bullet to move from C to Y or Y to C. Now for vertical journey, initial speed is actually 0, acceleration is g, so s is equal to ut plus half gt square gives s is equal to half gt square. So this s is actually vertical distance, this s is horizontal distance, sy or vertical distance, sx is horizontal distance. You have to find out sx upon sy, which is horizontal distance divided by vertical distance. You will get, after simplification, option D as your correct answer, 2v upon gt. In this case, you have to find out the acceleration of the object when rising, when at maximum height, when the object is falling. If you make the graph of the journey of the object, the vt graph, it will be like this. The gradient of vt graph is acceleration, and as you can see, the gradient is always constant and negative, so it will be minus 9.81 meters per second square, and it is never 0 because the gradient is never 0. A science museum designed an experiment to show the fall of a feather in a vertical glass vacuum tube. The time of fall from rest is to be close to 0.5 seconds, and you have to find out the length. Make the data: initial speed 0, acceleration 9.81 meters per second square times 0.5, and find out the distance. So by the equation you can find out the distance to be 1.225 seconds, 1.225 meters. So the tube must be slightly bigger than this distance because you have to find out the time, which is close to 0.5 second, not exactly 0.5 second. So it should be 1.3 meters. In this case, you have been given a distance L, a feather in a vacuum tube covers in time t. Now you have to find out how much distance the feather will cover when the time is 0.50 t. So there are two conditions, initial and final, as we have already done before, which means initial condition. This is the data where u is 0, acceleration 9.81 meters per second square, distance traveled is L, and this is the time in which the distance was traveled. Now after the second condition, u is 0, a is 9.81, t is 0.5, capital T, and s is x, which is unknown. So by this equation, s is equal to ut plus half at square, ut is 0, and a is actually constant. So if you make a subject, you will see that half a is equal to s upon t square. So this is actually constant, which means s1 upon t1 square is equal to s2 upon t2 square, where s1 is initial distance, initial time, final distance, final time. You have to find out the distance finally, which means in 0.50 t, right? So I'm substituting the values to find out s2. S2 in terms of L is actually 0.25 L, right? By this working. Bicycle brakes so that it undergoes uniform acceleration from 8 to uniform deceleration from 8 to 6 meters per second in 7 meters. The deceleration is same. Now you have to find out how much further will it travel before coming to rest. So there are two conditions, initial and final. In initial condition, the data is given so that you can find out the deceleration the object had. So by the working you can find out deceleration, which is actually found to be -2. Now you can use this same deceleration so that you can find out how much further the bicycle will travel before coming to rest. So I'm taking 6 meters per second initially because now it is at actually 6 meters per second, and now it has to be stopped in by traveling further distance, right? So u is 6, v is 0, a is -2, and you can find out the distance it will travel further, and it's found to be 9 meters. In this case, there are two trains, goods train and an express train. The goods train has a constant speed of 10 meters per second for time t, and express train was initially at rest and it accelerates with 0.5 meters per second square acceleration, and both trains come to a same point in time t. Of course they will travel same distance when they will approach each other. So you have to find out the time it takes for the express train to overtake the goods train, right? So making data for goods train, s is equal to vt. This is the distance traveled by goods train. Express train initially at rest accelerates 0.5 meters per second square. The distance the good express train travels is the same as the goods train because they have to meet at the same point. So the express train must travel the same distance as the goods train to come to the same point. So by the equation S is equal to ut plus half at square, instead of S I've written 10t because this is the distance traveled by the express train. Initial speed is 0, so 0 plus half 0.5 t square. Time is same for both of the trains because this is the time was actually started when the goods train express train starts covering distance and goods train passes the express train. So the time taken by the goods train and the express train to reach the distance is actually the same. So t is actually cancelled by t, and by the working you will find out time taken by the express train to reach the goods train is 40 seconds. In this question, initial speed is 50 meters per second, final speed is 10 meters per second, and the distance between the marker 1 and marker 2 is unknown, and the time to reach is actually 20 seconds between marker 1 and marker 2. So this is the data. Now you know that by equation 2 you can find out distance if v, u and t is given. There is another method to find out the distance if you do not know this equation. You can find out acceleration first, which is actually deceleration first, which is actually minus 2 meters per second square by this working. And now you can use the value of acceleration to find out distance by 2as is equal to v square minus u square, and this will be found to be 600 meters as it is found by equation 2 as well. An aeroplane travels at an average speed of 600 kilometers per hour on an outward flight and at 400 kilometers per hour on a return flight over the same distance. So distance is same. The speed while covering distance initially is 600 kilometers per hour, and when the aeroplane was returning it had the speed of 400 kilometers per hour. You have to find out average speed. Average speed is actually total distance upon total time. Total distance is actually 2x because it covered the same distance twice, once while going and once while returning. Now total distance is 2x divided by total time, which is t1 plus t2. T1 is the time taken while moving it was actually covering distance initially, and t2 is the time taken during return. Now time is actually distance upon speed, right? So distance is x, speed is 600 initially, and t2 is x upon 400. X is the distance covered and this is the speed by which the distance is covered. So instead of t1 and t2 we can write x upon 600 and x upon 400 simultaneously. Now if we take LCM it will become 2x upon 1200 and 5x, because 600 400 is actually the LCM of these two becomes 1200. 600 times 2 is 1200 and 400 times 3 is 1200. So 2x plus 3x is 5x. Now x will be cancelled by x, and the denominator of the denominator is actually numerator. So 2 times 1200 divided by 5 is 480, and this is the answer. I hope this worksheet will help you understand the concepts which are required in kinematics. If you like the video, if it was of help, please subscribe the channel and let others know about this as well. Thanks and best of luck.